Welcome back to The Explainer. So glad you're here. Look, if you're tuning in, you're obviously looking to get a grip on the absolute bleeding edge of power electronics, and you want it without the fluff, right? Well, today, we are unpacking something super exciting, Bronze Technology's incredibly cutting-edge silicon carbide or SiC MOSFET driver solutions. We're going to see exactly how they're engineering the future of high-efficiency power systems, literally from the ground up.
Okay, let's dive right into this. Think about those massive wind turbines or those huge, expansive solar arrays powering our modern world. They're incredible, right? But here's the catch. They demand extremely efficient, completely rock-solid power-driving solutions to operate safely. I mean, converting all that raw energy into usable grid power, that relies entirely on the tiny components managing those massive electrical loads. And that is exactly where silicon carbide technology steps in. It is an absolute game changer for revolutionizing efficiency.
So, here's our roadmap for today's explainer. We'll start with powering next-gen energy, then look at adaptable SiC driver solutions. After that, we'll dig into the self-developed core, take a peek inside 34mm and 62mm designs, and wrap up with designing the future. All right, Section 1, powering next-gen energy, and specifically the SiC MOSFET challenge. Moving right along to Section 2, adaptable SiC driver solutions, one solution, many packages. To really start our teardown journey, we've got to understand the core engineering problem here. It's about safely and efficiently driving 1200-volt SiC MOSFETs in modern systems. And honestly, that challenge requires incredible flexibility. So here is a simple but incredibly powerful capability. Bronze Tech's driving boards adapt to multiple SiC MOSFET packages. Seriously, these solutions are absolutely not a one-trick pony. Whether you're an engineer working with E2B, E3B, 83, XHP3, or even the widely used 34mm and 62mm standard modules, Bronze Tech has actually structured their hardware to dynamically cover all these varied packages. What does that mean for you? It means you don't have to reinvent the wheel every single time your form factor changes. Huge time saver. Okay, Section 3, the self-developed core, proprietary silicon advantage. Now, what's really interesting here is we are zooming right down onto the board itself. We're going to look at three critical, entirely self-developed components. This is what gives Bronze Tech a massive supply chain edge and a really holistic design advantage. Meet our first hero component right here, the BTP11521P forward DC-DC power chip. Honestly, it's almost surprising how much punch this little guy packs. Despite its microscopic SOP8 footprint, this proprietary chip delivers a rock-solid 6 watts of output power. It's basically providing that essential super-stable energy foundation that the rest of the driving circuitry needs to function flawlessly. Continuing our teardown, we arrive at the absolute heart of the operation, the BTD5350 MCWR. Now, this is a wide-body, single-channel, isolated driver chip, and it's enclosed in an SOW8 package. Think of this proprietary silicon as the central nervous system for the driving board. It's there to ensure rapid, highly precise signaling, all while maintaining that strict isolation you absolutely have to have when dealing with high-voltage silicon carbide systems. And rounding out this core triad, we have the TRP15DS23EE13 dual-channel isolated transformer. It's packaged in the EE13 format, and this component is designed specifically to output 2 watts of power per channel. It works perfectly in tandem with those driver and power chips we just talked about. Together, they ensure perfectly clean, isolated energy transfer across the entire board. Let's move to the data and see how this builds a complete picture. For the engineering audience tuning in, here is all that hard data cleanly consolidated for you. You've got the 6-watt SOP8 power chip, the wide-body isolated driver chip, and that EE13 transformer delivering 2 watts per channel. And here's the real kicker. Because all three of these core components are self-developed by Bronze Tech, designers gain an incredible advantage. I mean, it ensures perfect compatibility, right? But it also heavily reduces those annoying supply chain bottlenecks, and it allows for some highly optimized system tuning. So the crucial point here, the thing you really need to take away is this number right here, 10 amps. Thanks to that self-developed silicon, the driver chip can output a direct peak pull and sync current of 10 amps. Now, you might be wondering, why is this such a huge deal? Well, because it entirely eliminates the need for an external push-pull stage. Literally just gets rid of it. By removing those extra components, you're saving precious printed circuit board space, you're lowering the overall bill of materials, and you're significantly reducing potential points of failure. It's a massive win-win. All right, Section 4, inside 34mm and 62mm real-world reference designs. Let's guide ourselves out of the micro-level chips for a second and zoom back up to the macro level to see how all this integrates. And this brilliantly illustrates the scalability we've been talking about. So on one side, we have the BSRD 2427 board seamlessly driving a 34mm module. On the other, the BSRD 2503 board is driving a much larger 62mm module. And the cool part, despite the drastic difference in the physical size and footprint of those power modules, the underlying self-developed driving architecture from BronzeTech, it easily scales to meet the demands of both. No sweat. And finally, Section 5, Designing the Future, System-Level Advantages. So let's bring this whole thing together, right? Let's connect this technical teardown back to why this fundamentally matters for your next big design project. Here are your main actionable takeaways. By utilizing BronzeTech's solution, you're getting a plug-and-play, dual-channel board that just drastically reduces your development time. You're guaranteed that 2 watts of output power per channel, plus you get that incredibly vital 10-amp peak pull and sync current directly from the chip, which again strips away the need for that bulky external push-pull stage. Oh, and it confidently supports robust 1200-volt silicon carbide MOSFET power devices. Basically, what we're looking at here is a holistic, high-spec design that significantly reduces overall system complexity. Which leaves us with this final provocative thought. Now that you've seen the micro-level components that actually enable macro-level power efficiency, how are you going to apply this? Whether you're out there designing the next generation of solar inverters, or maybe pushing the very boundaries of wind energy conversion, what will you power next with BronzeTech? Thanks so much for joining me on this explainer today, and hey, keep innovating.